Hey everybody, we're going to now look at some solutions to our ticket to leave on 5.8 2020. Dun dun dun. Okay, first things first, what we have to do is remind everybody about Sohcahtoa and what it means. Sohcahtoa is an acronym to help you remember ratios. So the sine is the opposite side over the hypotenuse. The cosine is the adjacent over hypotenuse. The tangent is the opposite over adjacent. So now that we have that understanding of what the relationships are, we can now start to really answer the first question. And what is the first question? Well, it says, write the ratios for the sine, cosine, and tangent of a particular angle. That angle is what? Yeah, that's right, it's M. So that's the angle we're going to be looking at. We have to give two answers. We have to give an exact value and an approximate value out to 4 decimal places, right? So that's not the tenths, that's not the hundredths, that's not the thousandths, that's the what? The 10,000ths. Good. Okay, so here we go. Now, what we want to do first is locate the angle in question, and that is angle M. That's what everything here is looking at. M, 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 M. That's our angle in question. So the angle in question is M. So I'm going to make a little note here and say to myself, this is the angle I want to pay attention to. Now, what I'm going to do is start to label the triangle appropriately, okay? Based on that angle, okay? So, what should we do? Well, very easy. Let's break it down here. You can see that there are three things that we have to label in a triangle, right? There are three sides. There are three sides to a triangle. So in a right triangle, we always have a right angle. So always start there. You'll notice angle K has the right angle. I want to look across and then label that side as the hypotenuse. Okay? That's the first goal. Then what we have here is we're going to look at our angle in question. And remember, that was M, right? We made that note a little bit ago. Now I'm going to use a different color to point directly across and label this as the opposite side to that angle. Okay? And by default, the last angle is the last side will always be the adjacent side related to that angle in question. So that's what we're getting at here. Whoops. What is the angle in question? And remember, it's M. So once we've labeled our triangle appropriately, okay, we can now begin to process the problem. So it says, remember, read the ratios of Sohcahtoa to find the exact and approximate solutions. So, well, what are they? Well, remember the sine, right? The sine is the opposite over hypotenuse. So I simply put 40 over 41. Well, why am I saying that 40 is the opposite? Well, because it is. It's opposite to that particular angle in question, M. The hypotenuse is clearly 41 because the hypotenuse is 41. So then the adjacent side must be 9 units in length. Okay? So I just color coordinated them to make sure you understood how to label your triangle appropriately with respect to a particular angle. In this case, M. So you might be asking yourselves, well, how did I get this 0.9756, for example? Well, all I did was I put it into the calculator, that. So I literally just typed in 40 divided by 41, and it spits out this number. Remember to approximate it to the correct decimal place. Remember with rounding, if a number, if you have a number 5 or bigger, it's going to round up. If you have it lower than 5, it's going to not going to round at all, right? It's not going to round up. So I just put those numbers in. This divided by that gives me this. That divided by that gives me that. Okay? Now, do you need to be in degree mode here? No. Why? Because all we're dealing with are the ratios. Okay? Now, let's build in a little bit more. Okay? Now, with this next question, you'll notice that it says solve the right triangle. So what do we have to do? We basically have to find the missing sides, right? And one of the things that it does here is it says to find the measure of b first. Now, here's the thing about that. We can do that very easily, which is what I did down here, right? And as I said, it's nice to know the names of the theorems, but it's more important to understand the concepts of the theorems. And remember, how many degrees are there in a triangle? Remember, it's half a square, so it's 180 degrees, right? So, why is this all important? Okay. I'm pretty sure that the measure of angle B is 63, right? Because I just subtracted the sum of the other two angles away from 180. We knew one was 27 and one was 90. So add those up and subtract it away from 180. That gave us 63. Okay. I'm going to write it in, but I do not want to use this number, okay? But I'm going to do it out in two different ways. And the notes here provided give you an assessment of what to look for. Notice what I did. I started out with angle A. And why? Because it's given. When we are doing these types of calculations on like a standardized test or something, the best advice I can give you, okay, is use the numbers supplied in the problem. Okay? This is big. On a standardized test, don't use calculated values. So do not use calculated values within the problem to solve another part of the problem. Okay? So ideally, we shouldn't be using the angle 63 because technically it was calculated. So I did my calculations out by using the standards that we usually use in math. We use what's given to us, not what is calculated. Okay? Remember, Mathematics is a language that is very visual. It's a very conceptual and visual language. And we have to keep that in mind when addressing these types of problems. We don't want to insert an error based on our calculation, okay? And a small error can lead to a big final answer that's really different than what we should be expecting. So my advice, like I said, is to use the numbers provided, and that's what I did here. Just as a reminder, this little symbol right here means approximate, okay? So we've calculated that out. Now, what I'm going to do right now is, seeing that I've already given you the solutions for these, I'm going to try to show you that it doesn't really matter when you're working these problems out to a certain degree. But I'm pretty sure this is the way my math lab, see, this is the way my math lab, I think, thinks. Okay? It says, here, calculate this and use that, because now I can tell you it's correct, and then now it's correct, so you can use it. Logic. So I'm going to do the same problem, but this time we're going to take into the account the measure of angle B, which is equal to 63 degrees. Okay? So I'm going to do the problem out. I'm going to redraw it. So I have the basic right triangle that we have up there. Okay? I'm now going to put in the right angle, and I'm going to put in the information that was supplied. So this is A, C, B, and this was 25 units. And we knew this was 27 degrees, okay? And we knew that the hypotenuse was C, and we knew that this segment BC was A. So let me insert the 63. So now we can see that we're definitely dealing with the right triangle. But now we have to label it. And this, remember, is where I think people get into the only issue here, is labeling. So you want to label, in labeling your triangle. Okay, so this is an essential piece, right? And I'll probably get yelled at because in the American spelling, labeling is with one L. In the European spelling, it's with two L's, so it's like gray or gray, I guess. So if you want to correct me on it and put one L, that's fine too. But you want to label those sides that we discussed already in detail. And remember how we start. We start with the hypotenuse. There's the hypotenuse. So I label the hypotenuse, right? It's across from the right angle. Now I look at my angle that I want. In this case, it's 63. So 63 is now the opposite, okay? Opposite 25, that value of 25 is opposite the angle 63, okay? As basic as possible, which then leaves the last one as the adjacent side, okay? That's where we get it. Remember, we always label it in this way because then we're guaranteed generally not to make a massive error. So let's find A and C here really quick. Well, so to find A, so let's find A, find, well, let's say the approximate value of A. And what we'll do is we'll label it real quick, right? We know what we're looking for. We're looking for A. So which of the trig ratios are we going to use? Well, we have what? The opposite and the adjacent, right? Because the A is the adjacent side. And we know a value for the opposite, which is 25. So we are simply going to use the tangent, right? TOA, OA, opposite over adjacent. The tangent of 63 is equal to what over what? What should we put where? TOA, 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 TOA. Opposite, opposite. So 25 is the opposite, right? Over the what? The adjacent. Good. A, the adjacent. And then all we have to do is solve. So that's very easy to do. That says that A is equal to, for sure, the 25 divided by the tan of 63 degrees. Now, that's its exact solution. Its approximate solution is going to give you 12.7 roughly. Okay, that's its approximate value. So remember, this is the exact value. This is the approximate value. And we only had to round to the tenths. Now, let's just double check for a second. I'm going to be hopefully secure and say that this is our answer right here. Okay? Let's see. Do we have A? Oh, there it is. It's right there. Hey, look. Ding. 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 Look at that. They are the same gosh darn thing. So remember, when solving these problems, it's all a matter of perspective. Where are you? Where are you looking? And how are you going to look at that problem in a manner that makes sense mathematically in a language? So let's find C, the approximate value for C, really quick. And again, that's going to be, well, let's look what we have. C, we want to find C relative to 63 degrees. So that's the hypotenuse. And we have the what? The opposite. Which trig ratio, Sohcahtoa, sine, cosine, or tangent, is going to allow us to successfully solve for C? Yep, that's right. That's great. The sine, right? Opposite over hypotenuse. So the sine of 63 degrees is going to be equal to its opposite. Oh, that's 25. All over C. We are then going to do what? Solve for C. So that is, C gives the exact solution of what? Oh, I can make that clear. Is exactly what? 25 divided by the sine of 63 degrees. And if you run that through the calculator, you get an approximate value of 28.1 units. Okay? Is that the same thing that we got on the other side? Whoops. I don't know why that did that, but there we go. Isn't that exactly what we have here? Huh? Whoa! So there's lots of ways to solve problems, remember. So it's entirely up to you how to approach. But my advice would be this method on any type of standard examination, do not use a calculated value as the one we did over here, okay? But you will note that because we're rounding to such a small degree, I want to say degree, but to a small place, like the tenths, we can get away with a little bit of fudge matter, like right here, like 28.1, 28.1, right? It's not out to a whole bunch of decimal places. So hopefully that alleviates some problems with labeling and finding specific side distances to the legs or hypotenuse of a triangle. In the last example that we're going to do right now, we're going to describe the given angle as it relates to the situation in the diagram, okay? So you'll notice that I made an arrow and I called it theta E. Now, theta E is the angle of elevation. So elevation means what? I'm taking something like this and I'm rotating it up so I can see something up here. You okay? If I look at the other, then we call this an angle of depression. Right? Because we're looking downward. We can start at some point looking out towards our horizon, right? Swing down some distance and then look below that horizon. Okay? So that would be your angle of depression. So this is like looking with your eye like right out, straight in front of you. Okay? So the answer to this question, because we can clearly see that angle 1 is a positive slope in this case right here, which is helpful. And we can see that the angle of elevation is rotating upward. Then we can see that it is going to be an angle of elevation from the submarine, the bottom, all the way up to just the ship, and then it will continue to the tree. Hoping this helps, and let me know. Okay? Have a great day.